Welcome to tonight's video on 4-3. We're talking about derivatives of the exponential function. That's where you have the derivative of e to something, and the derivative of that, basically doing the chain rule, is e to the u times u prime. So, for example, the derivative of e to the x, well, that's equal to e to the u. U would be equal to x, so u prime would be 1. So basically it's e to the x times 1, which is just e to the x. Now if you have the derivative of e to the 2x squared plus 2x, now u is 2x squared plus 2x, or plus x, and u prime is 4x plus 1. So now you have e to the 2x squared plus x times 4x plus 1, which means the derivative is 4x plus 1 times e to the 2x squared plus x. So here you have a product rule. So we'll say f is equal to x squared. F prime is 2x. G is equal to e to the x. G prime is also e to the x. So when you do the product rule, it's x squared e to the x plus 2x e to the x. And that is the derivative. This next one is a chain rule. It is u to the 3 halves. So we have u to the 3 halves. And so u is e to the x plus 2. U prime is e to the x. So therefore, when you take the derivative of u to the 3 halves, it's going to be 3 halves u to the 1 half times u prime. So that's 3 halves 3 halves e to the x plus 2. Times e to the x. Well, this is 3 halves e to the x plus 3 times e to the x when you distribute that in. And then when you multiply by, we can't distribute that in. I forgot to put the 1 half here. So basically we can multiply these two. So we get 3 e to the x over 2, and that's times e to the x plus 2 to the 1 half. That's our final answer. All right, next page. This one we have a quotient rule. So the top, the f, the numerator is e to the x. F prime is also e to the x. The denominator, e to the x plus e to the negative x, with the derivative being e to the x minus e to the negative x. So then remember, with the quotient rule, the derivative, remember, it's f prime g minus g prime f all over g squared. So that means that it's e to the x times e to the x plus e to the negative x minus e to the x times e to the x minus e to the negative x all over e to the x plus e to the negative x squared. When you simplify here, you get e to the 2x plus e to the negative, actually e to the 0, because x plus negative x, remember when you multiply, you add the exponents, minus e to the 2x plus e to the 0, all over e to the x plus e to the negative x squared. Well, e to the 0 is 1, so 1 plus 1 is 2. These cancel each other out, so you get 2 over e to the x plus e to the negative x squared, and that is your derivative. All right, finding the inflection points of f of x equals e to the negative x squared. Remember, that's second derivative. So the first derivative, u would be negative x squared. So u prime would be negative 2x. So it would be e to the negative x squared times negative 2x. So basically it's negative 2x e to the negative x squared. That's the first derivative. The second derivative, you have to do the product rule. So f would be negative 2x. G would be e to the negative x squared. So f prime would be negative 2. G prime would be negative 2x e to the negative x squared. So when you do fg prime, so you get 4x squared when you multiply here, e to the negative x squared plus, and then you get negative 2 e to the negative x squared. So basically it's 4x squared e to the negative x squared minus 2e to the negative x squared. When you set that equal to 0, because that's what gives you the points of inflection, notice there's a common thing that you can factor out. So you can factor out e to the negative x squared, and that leaves you with 4x squared minus 2. When you set them equal to 0, both factors equal to 0. Notice this will never happen. You can't raise a number to a power and get 0. So this is no solution. But here, sorry, I meant to move the 2 over. Then divide. And then when you take the square root, you get plus or minus the square root of 1/2, which is equal to plus or minus 1 over the square root of 2. So that is the x-coordinate for the point of inflection. For the y, you're going to put 1 over the square root of 2 back in, and it doesn't matter plus or minus to the original, because you get negative, and then it doesn't matter plus or minus 1 over the square root of 2 squared. It'll give you the same thing. So it's going to equal e. When you square 1 over the square root of 2, you get 1/2. So it's basically e to the negative 1/2. So the points of inflection are 1 square root of 2 e to the negative 1/2 and negative 1 over the square root of 2 e to the negative 1/2. Those are the 2 points of inflection. All right, the next question, you want to write the equation of a tangent line to the graph of this function at the point 0, 4. So notice you want the derivative. So this is u squared. U is equal to e to the 2x minus 3. U prime is equal to 2e to the 2x. So when you take the derivative here, it's going to be 2u times u prime, which means it's 2 times e to the 2x minus 3. And then it's going to be times 2e to the 2x. So when you distribute the 2 first, you get 2e to the 2x minus 6 times 2e to the 2x. And then here you're going to get 4e to the 4x. And then it's minus 12e to the 2x. And remember that we're going to put 0 in, right? Because that's the x coordinate. So it's going to be 4e to the 4 times 0 minus 12e to the 2 times 0. So basically, it's going to be 4e to the 0 minus 12e to the 0. Well, remember, e to the 0 is 1, so 4 minus 12 is equal to negative 8. So that is the slope. So if you go y minus 4 equals negative 8 times x minus 0. That is your equation of the tangent line. All right, implicit differentiation. This means when you have two variables and you're taking the derivative with respect to x here. So remember, here u is equal to xy. So u prime, and this is a product rule. So f is equal to x, f prime is 1, g is equal to y, g prime is dy dx. So basically you have x dy dx plus y. So remember, this would be e to the u times u prime. So it's e to the xy times x dy dx plus y plus 2x minus, and now here you do 2y and then dy dx equals 0 when you take the derivative. So once again here, you're going to distribute, so you get x e to the xy dy dx plus y e to the xy plus 2x minus 2y dy dx equals 0. Now remember, you want everything with a dy dx on one side. So we'll keep it and everything else will move. So we have x e xy dy dx minus 2y dy dx equals negative y e to the xy minus 2x. Then you factor out the dy dx. So you have x e to the xy minus 2y equals negative y e to the xy minus 2x. And then you divide. All over x e to the xy minus 2y. And that is dy dx. Alright, that concludes our video for this evening. If you have any questions, please feel free to ask in class. Otherwise, I will see you all next class. Have a good evening.